is the I'm studying in Institute of Aeronautical Engineering. I'm studying BTech first year Computer Science Engineering. Today we are going to discuss about finding higher powers of matrix by diagonalization method. Before going to diagonalization method, we need to learn some of these basic definitions. Characteristic equation. For a square matrix C, the equation A minus lambda, data of A minus lambda equal to 0 is called a characteristic equation. If we solve by minusing lambda into I from the given square matrix, we can find the characteristic equation. From the characteristic equation, we can find the eigenvalues and eigenvectors. Eigenvalues and eigenvectors are to be used to be found the model matrix P. We'll discuss that one. Eigenvalues. The roots of characteristic equation are known as eigenvalues. These are also known as characteristic roots and related roots. Eigenvalues are used to find the eigenvectors. Eigenvectors. Let lambda be an eigenvalue. See, from eigenvalue we'll find the eigenvector. Let lambda be an eigenvalue of a square matrix a non-zero column vector x, such that A minus lambda I into x is called an eigenvector. For finding the characteristic equation, we will do the det, but in eigenvectors, we will not use the det. Okay, here we come to the diagonalization method. A square matrix A is said to be diagonalizable if there exists a non-singular matrix P, such that P inverse A into B equal to D, where D is known as diagonal or spectral matrix, B is known as model matrix. To find the diagonalization matrix or to check whether a given square matrix is diagonalizable or not diagonalizable, first we need to find the model matrix P. P is also known as model matrix. To find the model matrix, we need to find the characteristic equation of the given square matrix. From the characteristic equation, we will find the eigenvalues. From the eigenvalues, we will find the eigenvectors, and from the eigenvectors, we'll find the model matrix P, and by substituting this formula D equal to P inverse C multiplied by A and multiplied by P, we'll find the diagonalizable matrix. If a matrix is not diagonalizable, wait must our process will be stopped in the middle only. A is diagonalizable matrix if it is similar to diagonal matrix. A is diagonalizable if it is similar to diagonal matrix. It means upper triangular matrix and lower triangular matrix are zero. Only diagonal elements are present in the matrix. It is diagonalizable. N by n matrix is diagonalizable if it possesses n linearly independent vectors. If the eigenvalues, three eigenvalues are different, then a matrix is definitely diagonalizable. See here, be patient that I need to take only square matrix, same rows and same columns n by n. A matrix with distinct eigenvalues is definitely diagonalizable. Spectral matrix. Spectral matrix is also known as diagonal matrix. The spectrum of a matrix is set of its eigenvalues. More generally, if a linear operator over any finite dimensional vector space, its spectrum is a set of scalars such that it is not invertible. See, a diagonalizable matrix or model matrix. The model matrix is invertible, but diagonalizable matrix, the spectral matrix, is not invertible. Okay. The determinant of a matrix is equals to the product of its eigenvalues. Uh, For finding the diagonalizable matrix, we need to substitute in formula D equal to P inverse AP to find the first we need to find the model matrix. Model matrix. The matrix used to transform the given matrix into diagonal matrix is called transformation matrix or model matrix. Model matrix is denoted by P. Spectral matrix is also known as diagonal matrix is denoted by capital D. Calculations of higher powers of matrix using diagonalizable method. First, for, before calculating highest powers, we need to calculate a diagonalizable matrix. Diagonalizable matrix can be calculated by calculating model matrix. Model matrix can be calculated by the eigenvectors. Eigenvectors can be calculated by the eigenvalues of a characteristic equation. Characteristic equation will be calculated from using that of A minus lambda equal to 0 for our given n by n square matrix. Okay, after calculating model matrix, we need to substitute this form. After calculating the model matrix, we need to calculate the inverse of model matrix is also known as P inverse. After finding all these values, we need to substitute this formula. D equal to P inverse into A into P. Okay, D is not also known as spectral matrix or diagonal matrix. P is model matrix. A is given square matrix n by n, same rows and same columns. P inverse is also known P inverse of model matrix. Okay, till here we have find the diagonalized matrix. From this matrix, we need to calculate its highest power of given square matrix. we will calculate the highest force of given square matrix is also known as a power n. Is denoted by a power n. N is the power we need to find. A power n equal to p into d power n into p inverse. Okay. P and P inverse are the same as we calculated them for finding the diagonalizable matrix or spectral matrix. A power n is the power of given square matrix, we need to calculate it. D power n is power of diagonal matrix or spectral matrix. Okay. Uh, if we need, for example, if we need to calculate A cube, we need to calculate D cube. And so we are multiplying that D into n times. The simple trick to remember this formula is to obtain A power n, we need to pre-multiply by P and post-multiply by P inverse. Here are some examples. First question, diagonalize the matrix and find A cube. Given A is 3 by 3 matrix, 3 rows and 3 columns, A is 1, 1, 3, 1, 5, 1 and 3, 1, 1. To find the characteristic equation, we need to solve by using this det of A minus lambda equal to 0. Okay, A is 1, 1, 3, 1, 5, 1, 3, 1, 1 minus lambda is I is the integer matrix. I is the unity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 into lambda. For calculating, subtracting both, we'll get the resultant matrix as 1 minus lambda 1, 3, 1, 5 minus lambda 1, 3, 1, 1 minus lambda equal to 0. And after we need to calculate data of it. So for det, for solving det, 1 minus lambda is multiplied by 5 minus lambda and 1 minus lambda and minus 1 minus 1 into 1 minus lambda minus 3 plus 3 into 1 minus 3 into 1 minus lambda is equals to 0. After calculating this, we will find the characteristic equation as lambda cube minus 7 lambda square plus 36 equal to 0. Treat it as equation 1. After solving equation 1, we will get the 3 roots because its power is 3. 3 roots are known as characteristic roots, latent roots or eigenvalues. From 1 implies that let lambda 1, we'll get the 3 values, let it be lambda 1, lambda 2, lambda 3. Both lambda 1, lambda 2, lambda 3 be the roots of equation 1. It is known as characteristic equation. Lambda 1 equals to minus 2, lambda 2 equals to 6, lambda 3 equals to 3. And we need to calculate, actually we calculated eigenvalues. Now we need to calculate it. Now we need to calculate eigenvectors from these eigenvalues. First, we'll calculate eigenvector for lambda equal to minus 2. First eigenvalue. Okay, 3, 1, 3, 1, 1, 7, 1, 3, 1, 3 is the square matrix after substituting lambda at the diagonal position into x1, x2, x3 equal to 0, 0, 0. Okay, now this matrix 3, 1, 3, 1, 7, 1, after applying this lambda at eigenvalue at diagonal, we need to make it as to echelon form to easy calculation. R3 to find it echelon form, we need to use only row operations, not column operations. R3 gives R3 minus R1. R3 gives R3 minus R1. Calculating the draw operation, we will get the resultant matrix as 3, 1, 3, 1, 7, 1, 0, 0, 0 into x1, x2, x3 equal to 0, 0, 0. Okay, now we will calculate equation. From the resultant matrix, we got two equations named as 2 and 3. 3x1 plus x2 plus 3x3 is a 3x3 equal to 0 is equation 2. x1 plus 7x2 plus x3 equal to 0 is equation 3. After solving both equations, equation 2 and equation 3, we will get the three values because there are three variables. The three values are x1 equals to minus 20, x2 equals to 0 and x3 equal to 20. Eigenvector for lambda equal to minus 2 is, okay, we calculated its eigenvector such as x1 equal to minus 20 into 0, minus 20, 0, 20. Taking common 20, we'll get eigenvector for lambda equal to minus 2 as minus 1, 0, 1. Next, we calculated eigenvector for lambda equal to minus 2. Next, we are going to calculate eigenvector for lambda equals to 6. Eigenvector for lambda equals to 6. Eigenvector for lambda equals to 6. Okay, after substituting 6 in diagonal position, we need to subtract it. Okay, 3, 1 minus 6 is minus 5 and below, it's below diagonal element. Okay, 5 minus 6 minus 1, 1 minus 6 again minus 5. The resultant matrix is minus 5 1 3 1 minus 1 1 3 1 minus 5 into x1 x2 x3 is equals to 0 0 0. Okay, now we'll write equations from this resultant matrix. Minus 5x1 plus x2 plus 3x3 is known as equation 4. X1 minus x2 plus x3 is equals to 0 is known as equation 5. After solving both equation 4 and 5, we will get three values because there are three variables involved in it. X1 equals to 1, x2 equal to 2, 1 minute, x2 is equals to 2 and x3 equals to 1. Okay, we found the eigenvector for equation for lambda equals to for eigenvector 6, eigenvector for lambda equal to 6 lambda equal to 6 is second eigenvalue. For first we solved it minus 1 0 1, and for second eigenvalue the eigenvector is treated as h2 1 2 1. Next we successfully calculated two eigenvectors for two eigenvalues. Next, third eigenvalue for lambda equal to 3. The resultant matrix after subtracting 3 from its diagonal elements minus 2, 1, 3, 1, 2, 1, 3, 1, minus 2 into x1, x2, x3 is equals to 0, 0, 0. Now we are calculating equations from the resultant matrix. Minus 2x1 plus x2 plus 3x3 equal to 0 is treated as equation 6. X1 plus 2x2 plus x3 equal to 0 is treated as equation 7. After solving both equations 6 and 7, we will get the three values because there are three variables involved. X1 equal to 1, x2 equals to minus 1, x3 equals to 1. Okay, we found the eigenvector for the eigenvalue lambda equals to 3. The eigenvector for lambda equals to 3 is x3, treated as x3 equals to 1 minus 1 1. Then we have successfully found three eigenvectors for three eigenvalues. After that, we need to find the model matrix P. Model matrix P is treated as matrix n by n matrix, then 3 by 3 matrix taken as square matrix given A. X1, x2, x3. We need to substitute the x1, x2, x3 eigenvectors in model matrix P. After substituting x1, x2, x3 in their positions, the model matrix will be as minus 1, 1, 1, 0, 2, minus 1, 1, 1, 1. Okay. Now we need to calculate P inverse. We need to calculate P inverse because to find the diagonalization matrix in the formula there is P inverse. So we need to calculate P inverse. For P, we calculate P inverse. P inverse for the model matrix it means that inverse of model matrix is minus 1 by 2, 0, 1 by 2. 1 by 6, 1 by 3, 1 by 6, 1 by 3 minus 1 by 3, 1 by 3. We have successfully calculated model matrix and its inverse. Now we need to calculate diagonalizable matrix. After that, we need to find a cube as given in the question. D is equals to minus 1 by 2, 0, 1 by 2, 1 by 6, 1 by 3, 1 by 6, 1 by 3, minus 1 by 3, 1 by 3. It's P inverse into A. A is given in the question 1, 1, 3, 1 by 1, 3, 1, 1 into minus 1, 1, 1, 0 to minus 1, 1, 1, 1. Okay. After multiplying these three, the resultant diagonalizable matrix is okay. Diagonalizable matrix is minus 2 0 0 0 6 0 0 0 3. Actually, this the given matrix, a 3 by 3 matrix is successfully diagonalizable. So we can calculate a cube for the given matrix by diagonalization method. To find a cube, actually we previously discussed formula a power n equal to p into d power n into p inverse. So a cube equal to p into d cube into p inverse. Okay, we have calculated d. To calculate d cube only, it is known as it is diagonal matrix, lower triangular matrix, and its upper triangular matrix is 0. So we can directly cube the values of values present in the matrix. D cube to find d cube, we need to multiply d 3 times. The resultant matrix of d cube is minus 8 0 0 0 to 1 6 0 0 0 20. D cube D cube is minus 8 0 0 0 to 1 6 0 0 0 27. Okay. After finding d cube, Simply we need to calculate a cube by substituting these values in formula. First, we need to substitute the value of p minus 1, 1, 1, 0 to minus 1, 1, 1, 1 into minus 8, 0, 0, 0 to 16, 0, 0, 0, 27 into p inverse. P inverse is minus 1 by 2, 0, 1 by 2, 1 by 6, 1 by 3, 1 by 6, 1 by 3, minus 1 by 3, 1 by 3. After multiplying these three matrices p into d cube into p inverse, we will successfully get the a cube. The resultant matrix of a cube is minus 3, 5, minus 1, minus 2, 2, minus 7, 1, 9, minus 3. We are successfully completing this. Next sum. Diagonalize the matrix A 1, 1, 1, 0, 2, 1, minus 4, 4, 3 and find A power 4. Here we need, in previous problem we calculated A cube, now we need to calculate A power 4. Okay, to find the given matrix is A and it's 3 by 3 matrix, so diagonalizable matrix also will be 3 by 3 matrix and model matrix will also be in 3 by 3. Everything will be the same. The cat to find the diagonalizable matrix, we need to calculate its model matrix. After calculating, for calculating its model matrix, we need to calculate eigenvector. For calculating its eigenvector, we need to calculate its eigenvalue. For calculating its eigenvalue, we need to find the characteristic equation of the matrix. To find the characteristic equation, okay, we need to solve it by delta of a minus lambda by using the formula delta of a minus lambda equals to 0. After solving delta of a minus lambda I is equals to 0, 1 minus lambda 1 1 0 2 minus lambda 1 minus 4 4 3 minus lambda is the resultant matrix. Now we are going to find its state 1 minus lambda into 2 minus lambda into 3 minus lambda minus 4 minus 0 0 minus 4 into 1 minus 2 minus lambda equal to 0. After calculating it, we will get the three values, three eigenvalues lambda equals to 1, 2 and 3. Now we need to calculate eigenvector, eigenvector or characteristic vector for these three eigenvalues. Solving eigenvector for lambda equals to 1. Subtracting the eigenvalue from its diagonal elements will result in a matrix as 0, 1, 1, 0, 1, 1, same, minus 4, 4, 2 into x, y, z or x1, x2, x3. We can say take it as anything because there are three different variables equal to 0, 0, 0. Now we will calculate its equation y plus z equal to 0, x, same y plus z equals to 0 and minus 4x plus 4y plus 2z equals to 0. Okay, from backward substitution, we are going to calculate let z equal to k up from the above equations. If z equal to k, y equal to minus k, then from above equations x equal to minus k by 2. We will known as x, y, z as minus k by 2, minus k, k, minus k by 2, 1, 2, 2. Okay, now we'll calculate we'll calculate same the process in the same manner. After calculating it, we'll calculate model matrix x1, x2, x3, 1, 1, 1, 2, 1, 1, minus 2, 0, 1. Okay, and after calculating, we'll substitute in the formula a power 4 equal to p d power 4 p inverse. D power 4 will calculate 1, 2, 3 is the diagonal elements is diagonalizable matrix. Power 4 equal to minus 99, 115, 65, minus 100, 116, 65, minus 160, minus 160, and 81. Thank you.